Good morning. Welcome to the lecture on refining of petroleum. In the earlier lecture, we had discussed about liquid fuels. There we have discussed the types of liquid fuels, and after that we have discussed about petroleum. In petroleum, basically we have discussed about the origin of petroleum. So in the earlier video, we had discussed the origin of petroleum. Here, origin is explained basing on two theories. First one is carbide theory, and second one is Angular's theory. This carbide theory can also be called as inorganic theory, and this angular theory as organic theory. So now coming to the modern method or modern theory of petroleum is the admixture of these two theories, both carbide theory and Angular's theory. So according to this theory, here the petroleum is formed due to natural calamities. So due to natural calamities, the big forests are submerged in Earth's crust. As a result, temperature, pressure will be developed, and due to radioactive decay, of various products, and due to bacterial decomposition, result in petroleum formation. So see here, so this is the Earth's crust. So big forests will be submerged due to natural calamities, and the temperature and pressure developed, and due to radioactive decay of various products and bacterial decomposition, petroleum will be formed under the impervious rock. So this oil we call it as petroleum. And the gas, this gas is nothing but natural gas. And the proof for this theory is the presence of chlorophyll and resins. So here what I said, the oil is nothing but petroleum, and this is natural gas. So this petroleum is formed under the impermeable rock. Now this petroleum can be obtained by digging oil wells. And how these oil wells will be digged means by passing compressed air. By passing compressed air, oil will be drilled. So this is called as oil drilling. Similarly, the gas, natural gas can also be obtained, and it is called as gas drilling. So this is about the mining of petroleum. So after collecting the crude oil from the earth's crust, we have to carry out the refining process. So refining of petroleum means it is the process of removal of impurities and separation of different fractions having different boiling points from petroleum. So this refining of petroleum is done in 4 stages. First stage is removal of solid impurities. So the crude oil is nothing but the oil which we are collecting from the earth's crust. The crude oil is an admixture of solid, liquid and gaseous impurities. They will contain a mixture of solid, liquid and gaseous impurities. If we allow that crude oil to stand like that for some time without disturbing, so if this is left undisturbed for some time, then heavy solid particles settle down. In general also, if we allow any liquid to settle for stand like that for some time, what are the solid particles will be there? They will settle down at the bottom. The same thing happens here, and gases will evaporate. And this on further centrifugation, solid impurities will be removed. How they can be removed means by filtration. This is how the solid impurities existing in the crude oil will be removed. Next, separation of water. So the crude oil obtained from Earth's crust will exist in a stable form of emulsion and brine. Stable form of emulsion and brine. When this is passed between highly charged electrodes, these will break emulsion films. Not only that, small droplets will coalesce to form large droplets. And they will be get separated from oil. So this method of separation of water is called as Cottrell's process. Next, third one is removal of harmful impurities. Crude oil in general contains sulfur as an impurity. So this sulfur will be treated with copper oxide. This copper oxide will convert sulfur into copper sulfide, which is an insoluble compound, and this can be separated or removed by filtration. And the compounds like sodium chloride, magnesium chloride may also exist in the crude oil. So these salts will be removed by electric desalting and dehydration. So the fourth stage is fractional distillation. Fractional distillation means it is the process of separation of various fractions in petroleum basing on differences in their boiling points. So the crude oil, which is free from the solid impurities, water and harmful impurities, will now pass through into a furnace. Here the crude oil will be heated so that vapors will be formed. Now these vapors will be passed into this fractionating column. So now the vapors are passed into this fractionating column. A fractionating column consists of a tall tower which consists of a number of trays. See, these are the trays, and the vapors which are entering into this fractionating column will move from bottom to top. As the vapors go up, the temperature of the vapors will decrease and slowly they condense into the different trays depending upon the boiling points. See here we are showing the movement of gases. After that they are condensing into liquid, and again these vapors will be moving up and basing on the boiling points they are condensing. The fractionating column is provided with a number of side tubes. These side tubes are meant for collecting the various fractions of petroleum. So as the vapors are moving up, the fractions which are having high boiling point will be coming out first, and the fractions having low boiling point in the last, and in the last we will be getting the uncondensed gases. So here these gases are called as uncondensed gases, which have boiling point less than 40 degrees centigrade. Here we will be getting the hydrocarbons from C1 to C4. That means methane, ethane, propane and butane. These uncondensed gases can be liquefied to LPG, can be used as domestic, industrial and motor fuel. And the next fraction is naphtha, which is collected at temperature of 60 to 100 degrees centigrade. Here we can get naphtha, petroleum either, gasoline. That means from hydrocarbons having carbon C5 to C10. These can be used as solvent, motor fuel and as solvent in dry cleaning. Coming to the next fraction, kerosene, which is collected at temperature of 175 to 325 degrees centigrade. So these will contain hydrocarbons from C10 to C16. Kerosene can be used as illuminant, as engine oil, that means engine fuel, and also used for preparing laboratory gas. Next one is diesel oil, which is collected at a temperature of 250 to 350 degrees centigrade. Here this contains hydrocarbons from C10 to C18. This is used as diesel engine fuel. And the next fraction is lubricating oil, which is collected at a temperature of 300 to 370 degrees centigrade. This is used as a lubricant. Uses of lubricant and lubrication, all these we have discussed in our previous videos. And the next one is fuel oil. This fuel oil we can also call it as heavy oil, which contains hydrocarbons from C17 to C38. These are used for producing gasoline by cracking process. We will discuss in detail about this cracking process in the next video. And the last fraction we are collecting, we call it as residue, which is obtained at a temperature above 400 degrees centigrade. So here we will be getting asphalt and petroleum coke. Asphalt is used for laying roads and can be used as waterproofing of the roofs of houses, and this petroleum coke is used for molding rods of arc light. And it can also be used as a fuel. In the next video, we will discuss about in detail about this cracking of heavy oil. Thank you.